Guys, welcome back to my YouTube channel. Today we'll be dealing again with the strength of material N5. We're still under parallel bars, right? So yeah, we have given example 3.3, and then please, if it is your new time, if you are new, uh, or if it's your first time watching my videos, please subscribe to my YouTube channel and click that notification button so that you'll be notified whenever I post a new video. So okay, let us indulge in the question. They say here we have given a short concrete column. Here we have given the is reinforced with 4 steel bars of the diameter of that. Do you see that diameter there, which is 25 millimeter in diameter? The steel bars are placed as shown in figure 3.5 here. We see it. The square column is that. The square column there, as you can see at the bottom there. If I can show it by hidden detail, as you can see there, you'll have that. And support the axial mass of this. We see that axial mass, which is this is 80 ton. Determine the stress brought about in the steel and concrete. All right, brought about steel and concrete. So this is under parallel bars. So okay, guys, we want to calculate the stress brought about, but we have the areas. So we have 4. Take a note: 1, 2, 3, 4. We have 4 steels there. Make no mistakes about it. Do not make mistake when you find the area. Let us make them one thing. You can say the area of a steel. I will just write as represent steel. I will write as this will be 2 multiplied by that. Well, there are 4, isn't it? Sorry, we'll say 4. Then we know that the area is pi over 4 d squared. And the diameter, as I've seen, it said is 25 divided by 1000 will be 0.025. You square this like this, punch this immediately. Have this to be 1,963 times 10 to the minus 3 meter squared. What we can find also the area of the concrete. I will just write C. The concrete there, I will just say C. Concrete, now take notes. What the concrete? Remember, this is a compound. See, combination we've mixed. So to find the concrete, we must make sure that we remove. If we can remove these steels, then we'll be left with concrete. But however, if we have not removed this concrete, if we have not removed this steel, we must remove this steel. If we remove them, then we'll be left with concrete only. But as long as we don't remove that, that means we won't be left with concrete. But they want concrete, not the combination. If they say the combination is fine, but now they say they want the concrete. So because we know that they've given the area there inside, in other words, here we know is this is the same, the square. That means you'll multiply that will be 0.3, 0, is, you know, most is width. You know that area there will multiply of that, yeah, will be 0.3 when you divide that by 1000, multiply by 0.3. But now, or let me just explain, the area of a concrete will be the area of the concrete minus the total area of this object, because we want the concrete. Let the total area of that object, of that concrete column, the total area will be that total area that we have there, minus the area of the steel. Total area of that column we know will be like this. It's a square at bottom, minus the one of the steel you've just calculated there, which is 1,963 times 10 to the minus of 3. Then we have the area of the coulomb now of the concrete. I'm keeping saying the coulomb of the concrete. Then we'll have this to be 8,037 times 10 to the minus of 3. Remember, this is measured in that meter area. Now we have the area of the concrete. Remember, under the steel bar, we know that the extension of the steel is equal to the extension of what? Of the concrete. We know also total force is equal to force, will be equal to force of the steel plus the force of the what? Of the concrete. It's what we know under parallel, the formulas that we have. We'll rely on this. You can start by this, or you can, it's up to you, but let me start here because I don't know other informations. So can say this we know is force will be force of what? Steel multiplied by length of the steel divided by the area of what? Of the steel multiplied by Young modulus of the steel. This will be force of concrete multiplied by the length of concrete divided by area of the concrete multiplied by Young modulus of the concrete. So remember, but the lengths are equal. Length of the steel is equal to the length of the concrete. You know this. But these are equal. So that and that will cancel. We'll be left with this formula now. So since we left with this, this is what we have. I don't know the force of the steel, but the area I do know. We have just calculated them, isn't it? Which is we got 1,963 times 10 to the minus 3. Multiply this by the Young modulus of the steel. It is 20. This one is 13, so I won't forget that. 20 and 13, fine. 200, not 20. 200 times 10 to the minus 9. We know that. Then the force of the coulomb of the concrete, I don't know, but the area, it was 88,037 times 10 to the minus of 3. Then the Young modulus, the one I've said is 13 times 10 to the power of 9. This is what we have. Then now math, you can make the fs the subject. If you multiply by that, it will be 1,963 times 10 to the power of minus 3 multiplied by that fc like this. So simply punch the dear calculator here, and then we'll project this thing. Then the dear calculators, we punch the calculator there. Therefore our fs will be equal to what there? Punch all of these. Remember this actual the constants. You'll have that as your ratio there will be 0,347 multiplied by the force of the concrete. I've just said is C. So this is what we have. Right. We have this now. What do we have again? We can apply this force. we can apply this formula. So about that, then the formula that we can apply, F total equal to F of the steel plus F of the concrete. We have given that to be, we've given 80 ton. This is just the mass, remember, but it's in ton. That mass is in ton, but to be in kgs, remember mass must be in kg. Remember 1 kg it's equal to 1 ton. I want to say 1 ton it's equal to 1000 kgs. Then we have given 80 tons. You want this, you cross multiply, then therefore your kgs, your mass in kgs will be 80 multiplied by 1000. So yeah, remember, but this is still what the mass will be, the mass, but we want that to be newton. We'll multiply also by gravity because the force is what is mg. So that is what will happen there. So yeah, that will result as 80 times 10 to the power of what, 3 multiplied by 9,81. The force of this of the steel, here it is, we know, substitute that there, will be 0,347 multiplied by force of the concrete. Then can divide now by 0,347, both sides divide by 0,347. That and that will cancel, then I'll be left with that. Then if you punch your calculator there, you'll find this force of the concrete to be 584,309 kilonewtons. Right, this is what we have. Then they said we should calculate the stress, right? But we know that we can start by say stress of the concrete. We want these stresses of the concrete. We know the stress is force would be the force of the concrete over the area of the concrete. Then if you can substitute, we know that the force is 840,309 kilonewton. Right, you want to, if you can leave it, okay, then multiply by 10 to the power of 3. Remember, you convert that the area, we've got that, remember, of this, it was 88,037 times 10 to the minus 3. Then we simply punch these guys, then we'll have that the stress of the coulomb will be 6,637 megapascal if you have calculated this on your calculator. Then the force of the steel, we want the force of the steel. But now remember, how can we find the force of the steel? We'll take from here, it is here, there, as you can see. Okay, I can just, it is there, it is 0, that multiplied by that. So this, so the force of the concrete, it was this there, 584,309. so here we'll have 0,347 multiplied by 584,39. remember, use this in kilonewton. That means my force will be in kilonewtons. My force will be in kilonewtons there. Take note. Punch that will be 200,491 kilonewtons. Therefore, the stress in the steel, we know this will be force of the steel divided by area of the steel, then the force is there is 200,491 divide, okay, multiply by 10 power of 3 because it's in kilonewton there. Then you divide by that area that we got before. It was 1,963 times 10 to the minus of 3. Then if you punch that on your calculator, you're supposed to get, if you punch that, you'll get the stress of the steel to be equals to 102,109 megapascal. So that it is, guys. So yeah, so guys, nevertheless, please do not forget to subscribe to my YouTube channel and click that notification button so that you'll be notified whenever I post a new video. Feel free to like and comment and share this to your fellow classmates. No problem. Sharp. Thank you for watching.